We want to solve and graph each inequality and then express the solution using interval notation. The method for solving a linear inequality is the same as solving a linear equation, except when solving an inequality, if we multiply or divide by a negative, we must reverse the inequality symbol. One more thing you might notice about these two examples is the variable is on the right side. So to solve these, we'll start by isolating the variable on the right side of the inequality. So looking at the first example, we want to undo this subtraction and also undo this multiplication between the negative 5 and the x. And we always undo the addition or subtraction first, and since the opposite of minus 16 is plus 16, we're going to add 16 to both sides of this inequality. 4 plus 16 is 20. Bring down the inequality symbol. We have negative 5x, and then of course minus 16 plus 16 would be 0. And again, negative 5x means negative 5 times x, so the last step here is to divide both sides by negative 5. And since we're dividing by a negative, we do have to reverse the inequality symbol. So 20 divided by negative 5 is negative 4. We're going to reverse the inequality, so now instead of greater than, it's going to be less than. And then negative 5 divided by negative 5 is 1. 1 times x is x. So this is the solution expressed as an inequality, but it is more common to have the variable on the right side of the inequality. So we can reverse the order here as long as we also reverse the inequality symbol. So negative 4 less than x is equivalent to x greater than negative 4. Notice in both cases the inequality symbol is pointing toward the negative 4 and open toward the x. So these two are equivalent. This is just a more common way to express the solution. Now let's go ahead and graph this. And since x is greater than negative 4 is not in this interval. So to show that, we make an open point on negative 4. And then for numbers greater than negative 4, we make an arrow to the right. And as we continue to move right on the number line, we would be approaching positive infinity. And this is helpful to write this interval using interval notation. The interval is from negative 4 to infinity, not including negative 4. So we'd have negative 4 to infinity. So to show negative 4 is not in this interval, we'll make a rounded parenthesis here, and then for positive infinity, we always use a rounded parenthesis. So we've expressed the solution as an inequality, as a graph, and using interval notation. Now let's take a look at the second example. We want to isolate the x on the right side, so we want to undo this addition and undo this multiplication here. We want to undo the addition first, so we'll subtract 2 on both sides of the inequality. 9 minus 2 is 7. Bring down the inequality. We have 7x, and then plus 2 minus 2 would be 0. 7x means 7 times x, so we'll divide both sides by 7. Now here we're dividing by a positive, so we do not reverse the inequality symbol. So this would be 1 greater than or equal to, this would just be x. Again, this is our solution expressed as an inequality, but normally this is reversed, which does make it easier to graph. So 1 greater than or equal to x is equivalent to x less than or equal to 1. Again, notice the inequality is pointing toward the x in both cases and open toward the 1. So for x less than or equal to 1, notice that 1 does satisfy this inequality and therefore is in the interval. So to show this graphically, we'll now make a closed point on positive 1. Again, this indicates that 1 is in the interval. And then for numbers less than 1, we have an arrow to the left. As we move left on the number line, we would be approaching negative infinity, which means to express the interval from 1 to negative infinity using interval notation, we'll have negative infinity to positive 1, a rounded parenthesis before negative infinity, and then to show 1 is included, we make a square bracket. So again, we've expressed the solution 3 ways: as an inequality, as a graph, and using interval notation.